Hello everyone, and welcome to Jam Academy. This is an example of uniform circular motion. A block of mass m is suspended at the end of a string of length L. Now the ball moves around in a horizontal circle of radius r. We are required to calculate the tension in the string, the speed of the block, and the period of rotation of the block. Now, the most healthy place to begin a good problem like this is to start by drawing its free body diagram. So if we do its free body diagram, we have the weight of the block always acts vertically downwards. The tension in the string will act along the string in that direction. Now keep in mind that these are the only forces acting on the block. So our free body diagram looks a little bit like this. Mg and T. So if you observe, this angle is theta. That means that we can resolve the tension in the string into two components. This will be T cosine theta, and this will be T sine theta. So you see that in this particular system, the component of the tension, the horizontal component of the tension, is the force that provides the centripetal force for the system to move around in a circular path. Let's analyze the motion. The sum of forces in the y direction is equal to 0. What that means is that T cosine theta minus mg, this will be equal to 0. In other words, T cosine theta is equal to mg, which means that T will be equal to mg divided by cosine theta. This is the value or the expression for the tension in the string. So our next task is to derive an expression for the velocity of the system. We know for sure that the sum of forces along the radial direction is equal to ma radial. That would imply that T sine theta will be equal to mv squared over r. But what do we know about T? T is mg divided by cosine theta. So this would mean that mg divided by cosine theta multiplied by sine theta will be equal to mv squared over r. Now we have to be a little bit attentive here to simplify. Sine theta divided by cosine theta is equal to tan theta. So this would mean that mg, the tangent of theta, will be equal to mv squared over r. I can gladly submit to you that the m's can cancel. And if that is the case, we then have v squared over r equal to g, the tangent of theta. This implies that v squared is equal to rg, the tangent of theta. In other words, v is equal to the square root of rg, the tangent of theta. You see, this is a good expression, but I really don't like the expression. Why? The reason is because we have a variable in this expression that we don't know, the radius of the circle. If this was an experiment, I would like to express v in terms of what I know. Now, if you look at this diagram, this is r, this distance from here to here. And this is the hypotenuse, which is L. And if that is true, you will see that the sine of theta is equal to the opposite, which is r, divided by L. That means that r is equal to L, the sine of theta. Now, this is really great because we can measure theta and we know L. And if that is the case, V will become the square root of L sine theta multiplied by G, the tangent of theta, multiplied by G, the tangent of theta, which in turn implies that V is equal to the square root of LG sine theta tan theta. This is the expression for the speed of the particle in terms of given variables. Now, the next question is for us to calculate the period of rotation. The period of rotation. So how do we go about calculating the period of rotation? Remember that omega, let me use a different color, that omega is equal to 2 pi over t. And omega is equal to V over R. This implies that t will be equal to 2 pi r all divided by v. This is the expression for the period. In other words, this is equal to 2 pi r divided by the square root of g rg tan theta. If we want to simplify, t will be equal to 2 pi the square root of r squared divided by rg, the tangent of theta, which implies that t will be equal to 2 pi the square root of r divided by g, the tangent of theta. This is the expression for the period of rotation of the theta ball. Another way that we can see this is that the frequency will be equal to 1 over 2 pi the square root of g tan theta all divided by r. And this is the frequency of rotation of the block around the center of the circle. Now, if you have any questions, please, regarding this problem, I will appreciate it if you ask the question in the discussion forum. Thank you for your time and remain blessed. Bye-bye.